today we are going to implement a model that is known as the Ensemble learning model. But this model is not a new model, and in this model we will implement the base model, and by using the base model we will try to implement a new model that is known as the Ensemble learning model. So this is not a new model basically in the machine learning. This is the, we can say that this is extended version of the base model, and that is the point we need to keep in mind and see. It is basically it is inherent model in the practical way, we can say. So what we want to do right now, so let me explain here step by step. See, you can observe over here what the data set you have, it doesn't mean okay, but what is the model we want to use. So you can observe over integration recently classified support vector classifier was following by the support vector machine, of course, and Cannon classifier, that is also Cannon algorithm, and here we have the final prediction. So final prediction you can take from the various implementation of these four different models. Each and every model provides the own values in terms of the accuracy. Each and every model has own identity. But what we are doing right now in this today practical, of course, we will use a data set, and from the data set we will try to implement all these four different models, and each and every model you need to implement, and we will try to integrate all these models in a one group, and that is known as the ensemble. And based on the ensemble learning model we would try to predict something, and that is known as the final prediction. So each and every model also predicts something, but from this point what we're doing, after integrating all these models we will predict something from the its integrated model, and that is the ensemble learning model. So a result may matter or not, so few things depend on the data set. So before discussing more and more things, we need to understand each and every step properly. I hope you can understand in simple way. So from this point, just let me execute the first cell, what we have written over here, that is we have. Step by step, I will explain, step by step, I will tell you each and everything properly. Now, the next term we have over here, that is the performance of big learner. So what is mean by the big learner? So I have written over here, a big learner is a model, actually, it's a machine learning model, and that may have the error. So when you try to implement the logic regression, you can have the error, and you have the many models. So each and every no model is perfect in this world. So what you are doing, you are just trying to do something over here. So an ensemble model will should not contain an error. That is the point we need to. So the purpose of the ensemble learning model is implementation to make our model as a strong learner. So by default, we have any model in the machine learning that is also considered into the big learner, because no model in this world provides the 100% accuracy. But you will say, sir, we got the 100% accuracy so many times. Of course, you can get it, but you always perform many activities based on the small amount of data, and that is a not good way. But when we have the huge amount data set, so I hope you can get accuracy score approximately 85%, 90%, 95, maximum 99. But at the time you are not able to get the 100% accuracy. And if you're getting the 100% accuracy of the non-huge amount data set, it means your model is perfect. So nothing is perfect in this world, but we have so many problems on which we can determine something properly. So performance of the big learner we need to measure, that is our first responsibility. So on this point, we can say what are the errors, what is the accuracy we are getting, on which we can say are these model are big learner or not. But here today we will see use a small amount data set. So there may be some chance we can have the 100% accuracy, but this only be due to the reason of the small amount of data set. But when we have the thousand information, or when we have the thousand data set, at the time, that is our responsibility. We need to see we are not getting the accuracy more than 95% or 98%. That is the reason, because everything depends on the data set. But here there may be some circumstances on which we can get it. Due to one reason, we have the small amount data set. So the definition you must keep in mind: a big learner is a model that may have errors, and of course, that is the point we need to keep in mind. So first, we are trying to import something over here. Before importing anything for building our model, just let me know once again to all the people. The definition of the big learner is clear. Just tell me right now. The definition of the big learner is clear.
Yes, sir.
Yes,
Yes,
sir.
sir. Yes, sir.
Okay, good, good. So next point is saying to us, or this is the first step where we are need to do. We are just trying to import some libraries to build our base models. So what are the base models? You can observe over here, we have the base model. Here we have the base model, that is a decentralized classifier. Just like the decentralized regressor, this class is also included a part of the our tree library, of course, putting by the sklearn package. So sklearn package is most important package in the Python program library, where we have the many function method by which we can implement various machine learning model. So sklearn is the name of the package, and dot what we have, that is tree, linear model, SVM neighbors, all these are the its library. And decentralized classifier, logical regression classifier, and of course SVC support vector machine classifier and K-never classifier. All these are the various class, and we will create the object of each and every class to make our model properly. So this is a part we have already done so many times, but we are just trying to do same thing over here to build our model as an ensemble learning model. But before building the ensemble learning model, it is our responsibility to make or these model or implement these models properly one by one. Okay, so that is my point. Here we need to keep in mind. So let me inform you all once again right now in the before doing anything over here, how many models we have, please keep in mind. Total we are using the four model. One is the logistical regression, next one is the descent tree, next one is the KNN, next one is the SVM. So these four model we will try to implement in our program. So that would be our first step, and let me execute in front of you. And why we are using NumPy? Of course, this is the important point we need to keep in mind. NumPy we are using because of the one reason. Why? Because NumPy is required when we need to perform some arithmetic operation. And Pandas library we are using to get the data from the Excel file or .csv file to represent our information in the form of the data frame. And what is a data frame? A data frame is nothing which is a collection of the information to represented by the rows and columns. And after this point, what I'm just using right now, so you can observe over here, I'm using the our previously used data set, that is the height, weight, and t-shirt size. So based on the height and weight, just trying to predict our information, that is the t-shirt size. And that is an important point we need to keep in mind. So you can observe over here, and we are using a data set name over here, that is Ensemble. So this Ensemble is nothing which is the name, this is just rename of the my previously used data set. That is following by the three important features. One is the height, weight, and t-shirt. So what I'm doing right now, I'm just doing simple work. That is, you can observe over here. I'm reading the data set, and from reading this data set, I'm just printing some information from the data set that is to be represented by the printing its features. So first step after initializing the some libraries or some importing the some libraries, we are doing something over here, that is we are trying to read our data set. And we have updated data set by putting the some incomplete missing information. So you can observe over here, I have done some amendment into the my data set, that we need to keep in mind. I am just put it into some blank. What do you mean by blank? Null value or not a number. So those are represented by the not a number or null values, as you can observe over here. So the point we need to keep in mind each and every time. Okay, so let me execute this code and see how many null values we are having over here. After printing this point, after displaying the data set, you can observe over here, just please focus on this over here. NN, we are having NN, NN. So what does it mean by the NN? NN means the not a number or null value. The total number of the records we have over here 0 to 28. The total total we have the 29. Okay, 29. This is the right. Tell me this database contains, this data set contains some null values. Is it clear?
Yes, sir.
So question you must ask, sir, why you are using to introduce this data set right now. We are using this data set because of the one reason, because a student asked me question, sir, can we use any data set which may have any null value? So that's why I'm putting over here, and in front of you, I'm just trying to remove the unnecessary information that is to be represented by the complete data set. So this data set or this data set is not a this data set is not a complete data set. This is the incomplete data set. Why? Because it is having by the some missing information. So that point you need to keep in mind. Okay. So from this point, what I need to do, I need to do some amendment. Okay. So what I'm doing right now, just let me explain over here once again. Here we have the data set which are indexed by the rows indexed by the 0 to 29. So if you want to know the size of this data set, then we need to follow the some syntax. That is the data set. So what is the data set? Data set is the name of the variable which are having by the entire information. So you can observe here. Okay. After this point, you can note down some important point. Whenever I need to make or whenever I need to get the size of this data set, a simple method, a simple variable we can use, that is a shape variable. So let me execute this code in front of you once again. Then you will be able to see. Yeah, we are getting something over here. That is, we are getting the 29 rows and 3 columns. So what does it mean by it contains? I can write over here. It contains 29 rows and 29 rows and 3 columns. Okay. After this point, it is clear to all right now. Tell me how many columns and how many rows we have. Just please tell me right now. This point is clear.
Yes, sir.
Okay. So after understanding this point, what we need to do, we need to drop those values which are having by the unnecessarily. So here, without any doubt, I'm doing something over here. What I'm doing right now, according to demand of the students, definitely I'm doing this activity. See, in this database, we have the incomplete or missing information. So what we need to do, we need to remove those rows and columns which are having a not a number, and we can use a drop any method to drop the, we can use a drop any method to drop null values based on the rows and columns and drop all rows with the NaN values. So we have to use the drop any method. You can use like this one. And after removing those not a number values, or that is we can say the dropping the rows and columns, what we do we have? We use or we can copy all the information in the form the update part, and that is to be stored by the DS1. So DS1 is a complete data set which are not having any not number value. And let me execute this code in front of you, then you will able to understand properly. So from this point, you are able to see the not number values which are having by the data set we have removed. So here we have the some values, and that is to be starting from the 0 to 28 index. But this is not a 0 to 28 index. It just representing the index value which are having by the which are having by the complete information only. So from this point, you can able to understand what is the size of this updated data set. That is the, let us check the total number of the rows in correct or without null values data set into I can write over here into data set. Okay, that is we can say into updated data set. So what is the updated data set? I have the DS1. Let me execute this code in front of you, then you will able to understand we are getting the its value, that is 28. So you can observe over here from the previous part, as I am showing once again, we had 29 rows following by the null values. But right now we are having the 18 rows. In this case, we don't have, or in this data set, we don't have any null values. And three, of course, will be the our features. Those are the our attributes: the height, weight, and t-shirt size. From this point, we can do one thing over here. What I can do? Suppose you want to use. Suppose you want to use this information 165, 161. Suppose you want to use this information to measure the t-shirt size. Then this data is already removed from the data set. So now the question comes in our mind, so now this is important data set, this I can't remove. So it is better idea to, can we use the entire row, or can we fill something into our t-shirt size? So definitely there is two options for making the our complete record. What is the method? Just I can try it over here, then you can understand properly. There are there are two methods. It's not two methods. There are two ways. There are two ways to make your data set as complete. One is to remove not a number or null values. And second option is saying to us to fill something, to fill something or some value to replace. This is to replace some values, some values by some values instead of not a but value. There is two methods. Okay. So right now we have the two options right now. Can anyone tell me which option we must go? We have the two options right now. We can use the data part. So this can be held by the our this data set. Okay. Actual data set contains the error. Error means not a number or not a number value. We can say null value. So we have removed. So DS1 is free from that part. So we have removed. Now second option is saying to us you can replace some values instead of the not a number. So here we have to use another data set that is a two. So how we can resolve this problem? So there is option, there is a beautiful option over here. We can fill the some values by using the forward fill method. Okay, so meaning that the values not a number will be updated by the or replaced by its previous or upper values. What do you mean by the previous upper values? So just let me explain by the original data set, then you can understand. Suppose here we have the this part. So what is its upper values from its column respectively? We have the L. So this value replaced by the L. Okay, and this value that is of 61 in the in 17 index value. We have the 163 and not a number. From this point, you can observe over here. This is just leaving by blank. So this can be filled by the its previous value in that respectively column. We have that is 61. So that is to be filled by the 61. And this approach is known as the forward filling method. This approach is known as the forward filling method. Okay. So from this point, what we are doing right now, I am doing something over here for betterment. I'm filling, I'm filling something over here. So what is the name of the method I can use? So you can observe over here. We have a fill any method just like a drop any method. So drop any method drop the not a number value based rows, and what we have the in the fill any method. So in the fill any method from the actual data set we have some information that is following by the not a number. So I'm just instead of removing, I'm just using those rows by filling the some information, and that can be identified by as a simple concept that you can observe over here. What is the method? That is a ffill. So ffill stands for the forward fill. So I can write over here in bracket, then you can understand properly. This is known as the ffill method. And what I need to use, I need to use the actual data set that is to be represented by the data set. And I'm just not using the DS1 because DS1 just use a name of the data set, a variable, which is having the only 18 rows because we have removed the null values. So in the annual data set variable, I'm just making over here to be represented by the 29 rows, and each and every column, each and every rows does not belong to the null values. Why? Because it is to be filled by the some values. And what are the values? Its upper values, previous values that is to be used by the its respectively column. So I'm using this syntax right now, and then you can see the result. So after executing this code, you can observe over here DS2. So DS2 is my new data set. So how many data set we have? Data set 1, data set 2, DS1, DS2. So let me write something over here, then you can understand properly. Okay. Dataset variable, dataset variable, dataset variable is the actual just contains. Please put right here. Contains the actual values, including contains the data, including not a number values. And if we're talking about the DS1 is just a data set variable which does not contain not a number value. And DS2 is what? DS2 is also, just let me write properly so you can understand, a data set variable which is using all rows and columns by filling or updating NaN values. Okay. Tell me right now, this concept is clear? Just tell me right now, this concept is clear?
Yes, sir.
Yes,
Okay,
sir.
good. So let me check once again the what is the total number of the we have. So here we have the DS2. DS2, let me execute this code and then you will be able to understand. After executing this code, we have the 29 rows and 3 columns. So here what we can say DS1 can be complete by removing the not a number values. DS2 can be complete data set by filling the or updating the null values. And data set itself is not a complete data set. So it is a incomplete. So from this point, just let me know from your side which data set I must use, DS1 or DS2. If I'm using DS1, then I have to use the 18 rows. If I need to use the DS2, then I have to use the 29 rows. Okay, that is the point you need to keep in mind. And just let me give my justification. You can observe over here the 17 numbers of row upon the index, of course, it is 18th row. It contains the 163 and 61, and it was the naughty number. But after filling, it is automatically adjusted by the previous one. Now, this is actual data set you can observe over here. 163 we have, but we don't have the 61 as well as we don't have the t-shirt size. But it is filled by the previous values. What is the previous value? That is 61 and L. So this one we have. So it is filled. That's why now this is the we have the 29 values and nothing at any point we don't have null value. So from this point, just let me know from your side once again which data set I must use. This is my question. DS1, DS2.
DS2, sir.
DS.
We have the two data set. One is the DS1 and DS2. And just let me write once again. DS1 contain 18 rows and DS2 contains 29 rows. So what is the columns which are having by the DS1 dataset? So let me execute this code once again. So DS1 is our updated or filter based dataset we are using right now, no problem. And while dataset variable contains the all data along with the not a number value. So let me see this code, and now you will be able to understand DS2. So DS2 is our data set which is having by the 29 rows, 29 rows without somebody is saying to without not a number value. Okay, so we are using this, and now you can see observe over here the height and weight are the two features which are belong to independent features, and t-shirt size is our variable or column or attribute that could be identified by as a dependent variable. So I'm choosing some values over here then through the x and y. So you can observe over here x contain the independent variable that is represented by the height and weight, and the ds2 and we can say the y is will be the our dependent variable. It is also known as the target variable or response variable, and that is to be identified by as a t-shirt size. I'm executing this code in front of you, then you can able to understand it contains the all the 29 rows. Now you can observe over. So I'm printing x and y. So let me execute once again. So it is printing Now you can observe over here. So this is a total. We have the values 29 of the t-shirt size, and here we have the total 29 values of the height and weight. After this point, I am just copying this code from the previous class that we have seen into the information that should be transformed to non-integer to integer. And for this one, what we have to use the label encoder class, and that is to be part of our pre-processing library from the SQL package, of course. So as we know, the t-shirt size value is basically represented by the non-integer value, and if we need to perform some mathematical calculation operation, anything what we want to do as per our requirement, then we have to transform these non-integer values into the integer value. So we can do or we can perform any operation without any problem. So here we have the code Dawai which we can do. So this code I'm just taking from my previous lecture. So definitely no need to discuss more, but I'm telling right now in a small way, then you can understand. What we are doing here, we are importing the label encoder, a label encoder class from pre-processing library from sklearn package, and that is a simple term by which you need to keep in mind. So we are importing like this one. Okay, so there's a two different way by which we can do. So you can use this way, or if you want to use this one, then you can use. Okay, if you want to use this one, then you are not required to use this one. You have to remove this one. That is my point. So what you want to use, then you can use. It's up to you. Okay. So this time I'm changing like this one. Then we can see. So right now we are creating an object that is Ali. Ali means label object or label encoder object, and this is the label encoder object. Ali is the object of the label encoder class, and what is the to be represented by the y new? Okay, so y new basically is new variable. Here we have the new variable. It contains the information m and n. Okay, so y basically y is by default y contains the information into the y and n. Okay, so what we are doing right now, I'm writing over here. Uh, by default, by default, we have values in m and n of by variable. Okay, so that is a point we need to keep in mind. So what I'm doing, I'm just transforming, I'm just copying this y value into the by new, and I will perform some operation over here. And after this one, I will execute anything over here. I will transform by new value over here. Then you will be able to understand. So y will new contain the y new contain the mln values, and here I'm passing the values in respectively following by the y new variable into over here, and fit underscore transform function will transform these values into 0 1 format. Okay, so with help of the this label, and this values to be updated by the by new again. Okay, so why I'm doing this activity, because my new information of the y will not be updated. I will keep y as it is. Okay, so for this one, let me transform this point, and yes, right. Let me execute this code. Now, after executing this code, you can able to understand. Here is a label encoder. It should be small. Here we are getting the error. Here it should be okay. So after executing this code, now you will able to understand why it is contained by the by default values. That is default values. That is MLL. So we are printing the by MLL, and by new is updated by the transform values. So that is to be represented by the 1 1 0 and 0 and so on. So what does it mean by? So let me explain one thing over here, then you will be able to understand properly. See, 1 means M and 0 means L. Okay, that is the point you need to keep in mind. So I can write this statement once again over here. 1 means M and 0 means L. And after executing this point, what we need to do? We need to update here. We have transform R M and L values into 1 and 0, 1 and 0. Now update y values, y variable, okay, and y variable by updated values. Okay, so what I need to do, I'm just doing nothing. I'm just replacing or assigning some value. And because when you contain the information 1110, let me execute this code, and now it has been transformed. Now this point is clear. Tell me right now, any doubt over here? This point is clear. Just tell me any doubt over here.
Yes, sir, it's clear.
Okay, so I am just moving to the next cell, and what I'm writing over here, so please read carefully. So far we have prepared data set, okay, and transform non-integer values to integer values. So what is the next step? So next step is split, or we can say the classify the data is to split your data set into training and testing. Okay. So now we are splitting our data set into training and testing. So of course, what is the method we have to use from the model collection library and from the sklearn package? Train underscore test underscore split method we will use to use this activity. From this point, just let me know what is the size of the testing data I must use, because I am taking here that 40%, but just according to you, I can update. If you want, please tell me right now what size I must take.
Sir, 0.25.
0.25, it means you are looking for the 25%. So 25% of the 29 will be around something value. So let us execute this code once again. Let me execute once again in front of you. Now let me check here what is the total number of the values of the testing data size we have over here. So of course, by help of the shape variable we can do. And just in front of you, I'm executing this code, then you will be able to understand. See, the 29 values belong to the total rows belong to the our training data, while 8 values belong to the our 25%. From this point, we need to start our building the model. So before building our model, our data set should be divided into two important parts. One is training data set by which we can build our model, and testing data set which is required to predict our model. Keep in mind, testing data set why we need to create. We need to create testing data set to predict our model, and that is an important point. And by the actual values of the testing data and predictive values of the testing data, we can check what the accuracy we are getting. Suppose we are having some error, it means we are not getting the 100% accuracy. So every model is not, each and every model in this world, nothing is perfect, because based on problem or based on data set you may have the 99% accuracy or maybe the 78% accuracy. So depend on your problem we can have. But if you are getting the 100% accuracy, so I am speaking once again because of the very small amount data set. So this is only data set 29, 30 rows I'm using only for the understanding the concept purpose only. I'm not using the actual practical. I'm not saying the actual data set right now. So if you want to use actual data set, definitely we can use. Then the next practical, of course, we will use a 10,000 data, 10,000 rows, 10,000 rows we will use, of course. And but before that, let us understand this part right now. So if we have the small amount data set where we can have some chance we can have the 100% accuracy. So we will not deny this statement. That is the point we need to keep in mind. So here, after getting this point right now, training and testing data set, now what is our responsibility? Here we are building our models. So we are not building the single model, we are building the 4 individuals models. What are those? Distributed classifier, logical regression, support vector machine, and of course, alias neighbor. So from this point, we need to build our model. So how we can build the? Of course, we need to import the respective libraries, and we need to build the object by passing some parameters. It's optional. If you want to pass, then it's okay, no problem. So we are building the first model, that is logic regression model. So model 1 will be known as the logic regression. Model 2 is the object that belong to the So here we are defining the, see what we are defining. We're defining the machine learning model by creating, I can write properly, then you can understand, by creating their objects. Okay, by creating their objects. So first model one belongs to the object of the logistic regression. Dysentery classifier, here we are passing the maximum depth, that is the 2. If you want to update, then you can update. But I'm taking only the small amount right now because we have the very small amount of the testing data set. And the training data set we have very limited, so we can update 2 to 5 maximum if you want, then you can, okay. See, maximum depth is that depth is defining the level or depth of the decision tree, at which level you want to represent your tree only. And support vector machine, we are not changing anything over here. We are using only default parameters, and we are not passing the kernel, what kind of kernel we are using, because we have a small amount data set and no need to pass the any other information. But in the coming part, of course, we will see. Don't worry. And Canon, we are using default thing, something over here. We are using the nearest neighbor 5. If you want to update 6 or 4, then you can update. I'm taking the 6. And include distance, I'm taking the this one. See, this neighbor should not be more than the 8. Oh, sorry, 21. Because our model will be built by the training. So this is the point. You can't take the 22. If you take, you will get an error. If you take 0, then you will get an error. So the range should be the 1 to 21, and better idea I'm taking only the 6 or 7, what you want to use. This is the point. After this point, I'm building the my model, and let us check what we are getting. So here what we have seen, we have built the model, or we can say we have defined the object. And through the object, by the object, we will fit our model. We will fit our model, and at the time, what we are doing, we are building our model towards the training data set. Okay. Same training data set we are using for each and every model. So how we can fit? We need to fit the models toward the training data set and training the machine learning model. So first model one M1, that is logic regression, is building. Let me execute this code in front of you. Now logic regression model is built. Now next I'm building the.
Excuse me, sir.
Yes, tell me.
Sir, in decision tree classifier, what this maximum depth means?
Maximum depth I'm speaking over here. Maximum depth is it means you are talking about the depth of the tree. Suppose you have the number of nodes. So how many number of the nodes you have depend on your number of training data size. So what is the training data size you have? You have the training data size 21. So I can write over here. So please, 21 is what? 21 is would be total node. Okay, total nodes in decision tree. In a decision tree. So based on this total number of the values, what the maximum depth of the tree you want to use. So this is what defining. So maximum depth is means depth of the tree based on 21 nodes. That is the point. Now, is it clear? Because we have the total number of nodes, and by using these 21 nodes, if you want to create a tree, then what would be the maximum depth you want to keep? That is the point. Now, is it clear? If you remember the tree, then you have seen if you remember some word level of the tree, okay, root of the tree, and depth of the tree, and child node, okay, parent node. That is my point. So here we're talking about the maximum depth you want to keep. So definitely you can't take maximum depth more than 20 or 21, because if you're choosing the root node to the last node, and each and every node contains its own node, so maximum you can have the 19, 20 node. That is a maximum. So depth would be the some values. That is the point. So definitely in this small program, I'm taking the very small values for understanding purpose. Now this is clear right now. Tell me.
Yes, sir.
Yeah.
After this one, I'm just executing once again. I'm just fitting the my model, regression model once again. I'm fitting the my model, recently classifier. So it is being created. Okay. Now fitting the my model, that's SBC. Now next model I'm building. Okay. So here 5 different model using the training data set to build its model. Now it is built. So now what we have done, we have built our 4 different models, and those are the logic regression, adjacency classifier, support vector classifier, and KNN. From this point, you need to understand, we need to predict, we need to get some prediction values over here. Okay, what we are doing right now, with the help of the testing data set, we need to predict something over here. We will do nothing. We just use the previous activity so far we have done. See, with the help of the prediction method, by passing the testing data size, what the model we have, model one, that is logic regression. So its prediction values will be identified by as a by prediction one, by prediction two, by prediction three, by prediction four, respectively, followed by the descent classifier, support vector classifier, and k nearest neighbor. So our model will contain our model. These three four models will respectively represented by the predictions value. And let me execute this code right now. So we have done the prediction. So we got the prediction. We have built the model. After building the model, we got the predictions. Okay. Here, based on the prediction values, what are the actual values to be of the holding by the testing data? Of course, by test. So actual values of testing data that is to be managed by the by test. And prediction by the LR means logical regression. You can observe over here that is to be managed by the by prediction. And descent classifier you can observe over here that is by prediction 2 and by prediction 3 and 4 be the HBC and Canon. And let me execute this code in front of you, then you will be able to understand here. Actual values we got that is the 0000. Okay, it means L. The t-shirt size we are getting from the testing data, that is we are getting only the this one. So how many zero we have? You can count 8 because testing data size will be the 8 and it is having we have prediction by the logic regression giving the this values. So from this point, small amount data set you can observe 100% accuracy is not we are getting by the logic regression. But few parameters are matching with the decentralized classifier and SPC is also just opposite of our testing data. And Kin is also having the some values. So only one values and AC1 values are matching. So from this point, you can predict anything based on your training data. If you change something about testing data size, so definitely our prediction may change. Okay, we will go with this code right now, no problem with this data as well. So here, let us understand the accuracy of the each and every model. But there is no need to require the confusion matrix. Just only this is only two. So I'm just printing this part right now, but there is no need to over here because we will get the accuracy score by which we can predict which model is better right now. So we can observe over here based on the same data set, based on the same problem or same data set we are using, but we have used a different approaches. And each and every approach is giving the own result. So at the time you will get confused and you will say, "Sir, this model is better." But maybe the suddenly you are changing the testing data size and you will get this model is just now updated. Now suppose after updating the testing data size, your logical solution is 0%. It may change to 100%. So depend on the problem and depend on the training or testing data set or everything depend on the data set. What the data set we have. So small amount data set is not sufficient to explain the or to provide the better result. If you want to get the better result, then use huge amount data set, and that is my opinion. But for understanding purpose, we will try to understand this idea. But whenever we need to measure the performance of this model, and why we are measuring the performance, because we are performing the we need to check the performance of the big learner. So all these models are the big learners because no model is just providing the 100% accuracy. That's why it is known as big learner because our model or we have the our models are also not providing the 100% accuracy. So they are also known as the big learner. So let me execute this code right now in front of you. Then you will be able to understand what is the confusion matrix we are getting and what is the values we are getting. So it's optional part, no problem. If you want to use, then you can use. So here we are getting the some values. That is the point. See, only the confusion matrix. But important part we have to cover over here, that is accuracy score. From this point, you will be able to understand if I need to calculate the accuracy of each and every model, then what I need to do is a simple idea. The what is the prediction value we have and what is the actual values we have. We need to get this parameter, and from this parameter we can get the accuracy from this point. So accuracy of the logic regression we will have, and that is to be represented by the 0 and 1. So I'm multiplying the 100% from the each and every values over here. Then you can easily see this part. Now, after executing this code, you will able to understand the accuracy of the logic regression. We got the 0%. The accuracy of the descent tree we got the 75%, and the support vector machine also providing the very we can say 0% accuracy, and Canaan model providing the 87.5. So everything is depend on the its data size. If you want to update, then we can update, and according to our information, we can get the our information properly. Let me update in front of you. Let me update something rather than the 25%. Suppose I am taking the 30%. 30% testing data size. So just let me execute this code. So now you can observe over here, the descent tree model is just updated by the 66.6%. Previously it was the 75%. And now Ken model support this one. And logic regression we have again 0, and support vector machine we also having the 0% accuracy. So from this point we need to understand ensemble learning model. So far we have implemented individual model. That was my point. So far we have implemented individual model, and that is the point we need to keep in mind. So the model which does not have the 100% accuracy, it means the model contains some error. And this is the reason we need to know these are known as the big learner model. Yes, tell me right now, this part is clear? This part is clear. Why these are known as a big learner? Because they can have a 0% accuracy, or maybe the 99.9%. So what is the error? 0.1% error. If you have the accuracy 99.9. So right now this part is clear. These models are known as a big learner. Is it clear? Just to
Yes,
tell
sir.
me right. Okay.
Yes, sir.
Yes, sir.
Okay. From this point, we will have to move to the next part of this lecture. That is important part. We need to try to implement the ensemble learning model. So what we are doing, as I told you, we had 4 different model: logic regression, Canaan,
Sir,
recently.
I have a doubt here.
Yes, yes, please tell me.
Sir, as you written here, if we don't have 100% accuracy, then all the models will be weak learner. So all are
See,
here weak learners.
yes, I can update the statement. Don't worry. The model which does not have 100% accuracy, so it means the model contains some errors. Of course, because we have the error, some error. Suppose I'm having error. Suppose now just tell me now 99.9% you are having the accuracy score. So what does contain 0.1%? You are having an error. So it is also an error. A model should have an 100% accuracy, then that model is known as a strong learner. But there is no guarantee. There is no guarantee we can have the 100% accuracy. Suppose in this world of you are getting the 100% accuracy from any model in the realistic. I'm talking about it now. The model will be perfect. That is my point. So there are some chance when each and every model contains some error. So the model which does not contain the 100% accuracy, or better accuracy, we can say, I can update my words, no problem, or we can say, or better accuracy. But at what parameter you will decide? So that is my point. At what parameter you will say we have the better accuracy? Suppose you are getting the accuracy 80%, then your model providing the 81%. So at the time you have the 90%, 19% error, because your model providing the 81% accuracy. But at the time you have decided the parameter, your model should have the error, or should have the accuracy 80%. Then your model will be the perfect model. But so that is not a good way. So here we have the simple terms, that is I'm writing over here the model which does not have 100% accuracy. It means we have some error. Okay. So if we have, oh, I can update this one, the model which does have uh, accuracy score accuracy score less than 100%. Okay, 100%. It means the model contains some error, and this is the reason it is known as the big learner. So now the statement I have updated, but the same sense we are having the same sense over here. Now this point is clear right now. Tell me, this point is clear.
Yes, sir. So all are here weak learners.
Yes, of course. See, in this world, no model is perfect. If it is so, pretty frankly speaking, you are using the Windows 10 in real life operating system, no problem. You are using the Windows 10 operating system. Again, it contains so many bugs. Now we are using the real MS Team. It contains so many bugs. So now Microsoft is working on the MS Team as well as the Windows, and Microsoft is trying to update those bugs. Now there is a biggest drawback of the Windows 10 when you plug in your network, when you try to connect your internet with the operating system will start automatically to remove the bugs. That is the biggest problem. So at the time you must have the good data on your mobile as well as your Wi-Fi. That is the reason. When I'm just trying to update, when trying to shut down to my system, most of the time I'm getting the Windows is updating. Why? Because internally Windows is trying to update the bugs. That is the reason. Okay, this is the point. Now clear? Yes. Now tell me, is it clear?
Yes, sir. Please.
Okay, so now I am just explaining the ensemble learning model. So how to integrate all these built models. So here what I'm doing right now, just please listen carefully. 4 models we have implemented. We are making the instance of these 4 metals 5 times. These 4 metals 5 times. So logical regression instance we are creating 5 times. Recently we are creating 5 times. KNN we are creating to 5 times. And next one we have our support vector machine. So we are creating its instance 5 times. So 20 in, so we can say the 4 into 5. 5 instance of each and every model. It means 4 models here. So 4 into 5, it would be 20 big learner models. We can say 20 big learner models we have, and these 20 big learners will be integrated in a group. That is the point we need to keep in mind, because at a time you have implemented it one time and you are getting the various result. But if you update, if you're using the different if you're using the training data set, and with our training data set, if you try to build your model again to check the performance, then 5 times we are implementing over here in simple way. So you can observe over here what I have written in this work. We have defined each of the 4 model machine learning models 5 times, and that result the combination of the total, that is we have the 4 machine learning model and to 5 times. So we have the 20 big learner, and then finally, then we will use the maximum voting classifier. And this is what, this is a classifier of the ensemble learning, and that is a part of the ensemble library. So we used to this first classifier, that is a part of the ensemble learning. We are the class which has been predicted mostly by the big learner and will be final class prediction of the ensemble model. So now we are not changing anything into the training data set or testing data. We will use same training data or testing data set over here. So now let me execute my code over here, and before that, let me explain each and every step properly. So defining hybrid, because we have the 4 different models, so why I'm saying it is a hybrid. So it is also known as the ensemble learning model. So we are just making the ensemble learning model by using the 4 big learner 5 times, 5 times instances, by using the 5 times instances. So means we are aggregating for all models as a one group, that is ensemble we are doing, and creating the sum model. And we have to use estimator. We have the variable, that is estimator. You can take any other variable name. I'm taking the technical term over here, that is estimator. This estimator will integrate all the information in a one group, and we are making this one as a tuple. So estimator is a variable. It contains the or append all the models details in a list, and why which we can do, of course, with help of the object. First, let me explain defining the 5 logistic regression models. Yes, of course. Model 1, 11, model 12, model 13, model 15, model 15. These are the 5 different model, and each and every model we will try to integrate. Okay. So logic regression, with our logic regression, we are just making, and logistic one is the name of the name of the this appendation. We can say that we are appending something. So this name we are giving just like a only the name. And we have the model 11. So model 11 is what, that is the object. So what we are doing, we are adding the logical relation by taking the object name over here, and we are giving the name, that is the logistic one only. So if you want to write your name, then you can write, no problem. We will use only the its object name, that is necessary part. So it is naming, because each and every information if you want to represent, it has the own value, the name. So what is the value name? Logistic. But what is the value on which we need to perform something over here? That is the model 1. Same thing we will go for the model 12, model 13, model 14, model 15. So this is how many times we are creating? 5 times logic regression. And let me print this estimated values, that is also known as the ensemble. Ensemble. This estimator is also what estimator we can say an ensemble variable. Okay, that integrate all the models together. Let me execute this code and see what is to be handled by this estimator variable. Let me execute. Now it is executed perfectly. Yes. Now I'm executing once again. Now you will be able to understand. We are getting this value. Same thing we will go for the dysentery. So in the dysentery, what I'm doing, I'm updating its maximum depth. So after changing the maximum depth, we have the 5 different dysentery models over here. We have the 5 dysentery model over here. Okay, so maximum depth, I'm passing 3, 4, 5, 2, 6. What you want to use, you can use. No problem. I can update like the 4, I can update the by 3, I can update by the 6 one. You want to use 7, then you can use. Then 2, problem I have update. Same thing, model 16 is the name of the object, and dysentery classifier, we are passing the parameter that is the maximum depth 4. And here we are making the name that is the card one. Why card one? Because dysentery classifier is also known as the card. And what is meant by the card? Card stands for the classifier and regression technique. Dysentery is good tool where we can do the classification regression properly without any doubt. I know we have the its advantage, disadvantage, but it is also known as a card. CRD card stands for the classification regression technique. And dysentery is the best example for the card whenever we have so many problems, such as logical regression, KNN, SVM. But this is the best example for the dysentery, and it's a fundamental part we're talking right now. And it supports the both approaches on the same data set at the same time. And of course, so this is the reason actually. And it provides a better result from the others when we have the small amount data set. But when we have the huge amount data set at the time, dysentery does not support the good way. And see, when we have the huge amount data set, then assume is better than the dysentery. But we have the small amount data set, then what we have observed. Now you can see once again. See, dysentery is providing the 66.6% result rather than the SVM providing the only the 0. That is the point. Because SVM is not suitable for the small amount of data set. I'm speaking so many times and I have spoken so many times these words. So here you can pass the DT1, DT2, what you want to, it's only the name only. So, but I'm using the card one because what is the card? Because when you try to hard this term, card stands for the classifier, classification and regression technique, or it's also known as the classifier and regression technique. I'm adding or appending the estimator variable, and after the logistic, it append the its each and every information over here. So I'm executing this code. Now this is executed. Okay, what I have updated the 4367272. So let me execute this code once again in front of you, and it is executing. Same thing we will do this with the SBC. So what I can update the SBC by passing the its parameter that is the linear. Kernel function I am using the linear. I can use the kernel function poly. I can use the kernel function RVF. Okay, radial basis function. Okay, so with the help of the passing the different parameter, I can make my model different way 5 times. So I'm making the SVM model or SPC model, SPC classifier with a different way like this one. Same thing I will append and I will add over here. See, so now it is added. So you can observe over here. See, it is created. See, it is created 2 times. Okay, it is created 2 times. So just let me right now correct because it is 5 times we are creating. Here we are creating the 10 times, and here we are creating the this time. So 20 we can use maximum, but here dysentery class generated by the 10 times. So let me regenerate or re-execute this code. Now see, this is the reason. So let me execute this code once again, and see we will have an error, of course, definitely to avoid the error. So that's why I need to execute only 5 times only. Let me execute this one 5 times. Yes, this is generated. Yes. Now we have got the our 5 times only. See, if you are having the more than 5 times, it means what you are having the error. So because 5 times you have the logistic, 10 times you have the dysentery. So equality is required. But dysentery is represented by the 10 times, and that is unequal way. So definitely we can have error. We got the error, so that's why I'm just troubleshooting right now. And now we need to go for the SBC. So I'm going to SBC. Now let me check once again here. No problem. Logistic 5 times, generating dysentery 5 times, and SVM is creating 5 times. No problem. Same thing, we can update the change. We can change the case value. So by which we can update over here. So if you want to update, then you can update. So I'm just going through this code, and what you do after each and every time you need to update the its value, that is to be estimator. And let me execute this code once again over here and see. Yes, it is created. Yes. So 5 times logistic we have, 5 times dysentery we have, 5 times SBM we have, and 5 times KNN we have. Total we have the 20, and equal we have the instance of each and every model. And now we need to, at what we need to do, and at the last what we need to do, we need to ensemble or aggregate, ensemble, or we can say, I can write, or aggregate our models by using the estimator variables. So what is the name of the our variable? That is estimator variable, that is the estimator. Okay. And defining the ensemble model. So before defining the ensemble model, just let us understand what is the estimator. Estimator is the name of the variable which is used to integrate, or which is used to aggregate our instance of the various models. So we have done. So how we can use the our classifier, that is the example of the ensemble learning. So if you remember the example of the classifier type 1, that is we have the stacking. Stacking, by which what we have done with the help of the stacking, we can use, or we have done, we can use voting classifier, we can use the random forest classifier over here, we can use the adaboost. So adaboost or random forest I will demonstrate later on to classify purpose only. But this is the example I am taking right now, voting classifier. Instead of the voting classifier, you can use a random classifier, random forest classifier. Instead of the random forest classifier, you can use the adaboost classifier, what you want to use. But right now I am using only the voting classifier. Why? Because we are using voting classifier because it's a basic ensemble learning model when you try to learn something. But others are the bagging classifier and boosting classifier. And bagging we can understand by the random forest. Okay. And so this part we will discuss next in the next class, no problem. But in the boosting, what we need to do? Boosting, we can use the add a boost classifier. Okay. So this is a good example by which we can solve our problem. So after using this class, and ensemble will be our library. This is the point you need to keep in mind. From this point, I need to keep the variable. What I need to pass, we need to pass an estimator variable, and that must contain all the models as our desire, and it contains all the models instance over here. So I'm passing this one value right now. And voting classifier, I'm using the object ensemble. If you want to use any other variable, you can use. And I need to fit my model like the other model. We have to fit our ensemble model with same training data. Okay, that is the point. Training data set. I did not change anything. And we need to predict the ensemble model like other. So we are also using with the same testing data set. Okay. So what we have done, we have built the model here. We have fit our model, and we have test our model by prediction way we have done. And what is the actual values of the by test we have, and what is the prediction value we are getting by getting the our voting classifier. So by prediction is the name of the variable which is the prediction values of the voting classifier. And let me execute this code in front of you, then you will be able to understand. Now see, the actual values we have this one, actual values we have this one, but our model is giving the 0 0 1, or we can say the L and so on so value. Why? Because from this integration we have some models by which we are getting the some accuracy, that is 77% or 66. So it is it is not providing the average value. It is just predicted by the some values that could be better than the other model. So this is a classifier, or this is the ensemble learning model where we have integrated each and everything properly. From this point, if I try to calculate the confusion matrix, then you will be able to understand C properly. And after this point, let me see. Here we are getting the accuracy 55%. See, here we are getting the accuracy of the ensemble model 55%. So suppose we have the logic regression good way, we have the other way good way 88%. So our model provide the good better result. So everything is dependent on the data set. Okay, so that is the point you need to keep in mind. Training data set or testing data sets must be properly, and your actual data set must be properly before defining anything. So why in the CM you are getting the 5 pool total 9? Why 9? Because I have updated my testing data set by the 25%, 30%. Okay, so 30 to 25. So we are getting the increase this way. That is the point. And accuracy we are getting the on the prediction that is to be done by the our prediction by the, okay, here what we are passing, just let me write. Prediction value of ensemble model and actual testing value. That is the point we need to keep in mind. And we are getting the accuracy, we are getting the accuracy 55%. Now tell me, this is point is clear? And this is just idea about the ensemble learning, how we can integrate.